Hi, my name is Aaron, and I'm going to be going over task 1 for our project. For task 1, we asked for 3 inputs in our GUI. Location, which was stored as a string, a graphical user input, which was stored as a pair of x and y coordinates, and a date input, which was also stored as a string. These were all stored based upon time input, either morning, noon, or afternoon, and based upon which time input was given, data would be collected. All right, so we move on. Here, this is the function task1 var create, which initializes all the variables for data collection, morning, noon, and afternoon, so that we don't have to initialize them in the GUI, which could cause a problem if we were to do so. Here's the picture of the GUI. As you can see up here, we input the date. Here we can input the time of day, either morning, noon, or late afternoon. We can also input the name of the location. When this button is clicked, you can choose a location on the axes. A crosshair will appear, and you'll be able to click the location you'd like to collect the data. And based upon where you click, the inputs will be stored. Alright, so here is the code that runs on the push button. As you can see right here, we ask for an input. And as long as that input is positive, which means it's on the picture itself, it will run this code. And so, for example, if they choose morning, it will load the morning file, and we'll go through, find the first empty row in morning, and store first the coordinates, or in the second array, the coordinates. This is the storing of the location string. Here's the storing of the date string. And then we initialize two 3 by 255 matrices, which are going to be used for data collection. And this last variable is just the number for the trial based on what trial we're running. And the same thing goes for noon and afternoon. And lastly, all of the variables are saved and appended to based on what input we use.
Hi, my name is Saba, and I will be explaining part of the task 1 code as well as the flowchart for task 2. So the main part of the code that I'll be explaining has to do with running the actual Arduino and saving all our solar data. So first, of course, we have to load all the mat files here so we can actually store the data that we're collecting somewhere. And you'll see here that we have these warning dialog boxes that are going to pop out throughout the code, and these are mainly just reminders for the user to put the jumper back on, take the jumper off, and to reposition the solar panel in between trials to make sure you get the optimum amount of sunlight possible. So as you go down, we have a line here where it is assigning the port that the Arduino is plugged into so the computer and the Arduino can communicate with each other and store the data properly. And then we go down into the code that actually runs the data and stores solar values for the open circuit voltage. So it goes in here, it runs through 3 times since we're doing all 3 trials at once, and the data will be recorded, and depending on which time of day you have selected, either morning, noon, or afternoon, it will store the data into the correct cell array. And once all the trials for that is completed, it will of course save all the data, and then it will go on to the load sweep. Again, the code is really similar. The only main difference is that for the load sweep, both resistors inside the Arduino solar panel are set to the same resistance. It'll go through again 3 times, storing all the data in the correct .mat files depending on time of day. When all that is done, of course, it's all saved. And then after that, you move from location to location, and then you eventually collect all your solar data. So up next is the flowchart for task 2. It first asks the user for input for the time of day that they're collecting data, either the morning, noon, or afternoon. After that, you can select to see the raw data from your 3 different trials, so an average of those. You can then select to go to trial 1, and then of course you can plot the contour plot for the load and the open sweep data. Same thing if you want to do the second trial at that time of day. Again, they're the same options, the load data or the open sweep data, and the same exact thing happens with trial 3, load data and open data. The other option instead of raw data is just to do the average of the averages. So that will just be one value of solar data for the whole location at that time. And again, there's the load sweep and the open sweep data option.
Hi, I'm Raymond. I'm going to be explaining task 2, the GUI and the code. Alright, so this is the GUI. First, you select your time of day. For example, here I will select afternoon. Then you will select your data type, either raw or the average across the averages. For this example, I will pick average of averages. If you were to pick the raw data from the 3 times, you'd go to step 2.5, which is selecting which trial number you want. I'm not going to do that. And last, you will select your plot type, the maximum power point, aka load sweep, or the open circuit. I will pick maximum power point for this example. And when you click plot, give it a few seconds and it will produce a wonderful contour that looks like so. So we begin off this section of button code with loading our data files, followed by a bunch of initializations of variables I'm going to use later. This segment of code right here is quite important, and that would be setting the bounds of interpolation. So the image is first loaded here, the max x and y's are extracted from it, and then we create an array of going from 0 to that max, so we can mesh them all and get the combination of all the points that exist on that image. It will be important later. Here is where the averages are being calculated. It gets kind of messy because we append on to already existing and lengthy cell arrays, but it works. And so here in this inner loop is where we do the 3 trials for if the user picked like raw sweep per se, and that requires the calculation of 3 averages. And following that is the line for the averages of averages, which only requires 1 calculation done here. Next comes a pretty complicated part, and that's setting the z values for interpolation. Before, we've defined new x's and new y's in qx and qz for interpolation, and now it's time to set the z values. So it really depends on what the user chose. So for this example, I'm just say the user picked morning, load sweep, average of the raw data, and trial 1. And so if they picked all that, this loop will set the according z values into there. Right afterwards, the try-scattered interpolate function is used, and the inputs are those x coordinates, not the new ones, the old ones, the old y coordinates, and those z's we just created in this loop up here. Once that's done, we've created a interpolation function called f, and we feed it the new y's and the new x's to create new z's. So this is done for the open circuit voltage here. Before it was the load circuit or load sweep voltage. And all that is repeated for each case. Noon over here and afternoon over there. Here comes the code that actually plots the contour lines. So first, the image is loaded on the axes. The campus map is loaded on the axes. Then we contour it using this function right here. The qx's, the new x's and new y's you see here, and here's qz, and there's a bunch of other stuff here, and that's to scale the qz's so that we see the color gradient. Like from before, there was red in another area meaning highest, and then you move on and there's a bit of orange, and this is what does that.